We're going to go through this question here. It's another inequality one. You might like to pause the video and give it a crack yourself. All right, so what are we going to do here? First things first, let's make the bases the same. So we've got 3 raised to the 2x minus 1 is less than or equal to, now 9 is the same as 3 squared. Now we're in a situation where the bases are both greater than 1. So this is simply a matter of taking the indices, so this, and then just using that inequality as we see it. So to go back to this for a second, we're in this scenario here where a is greater than 1. So we can just say in this case, well, x is greater than y. So in other words, we're literally taking both indices and using the inequality that we see. So in this case, we take both indices and then use the inequality that we see. Okay, so that means we're going to get 2x minus 1 is less than or equal to 2, which means we're going to end up with 2x is less than or equal to 3, which means we're going to be left with x is less than or equal to 3 on 2. And that right there is our answer. That's what you do. Now, I want to show you an alternative way of answering this question, which relies on more of a graphical approach. So let's go alternatively. Alternatively, you can first graph what you've got. So if I was to graph this, let's do this and that. Let's look at each portion that we have. So we have 3 raised to the 2x minus 1. Now, there are no reflections happening here. We do have a horizontal shift and a dilation, but it's not really going to change what the general shape of this graph is going to look like. It's going to look like that. That's y is equal to 3, 2x minus 1. And then what else do we have here? We have 9. And this means we've just got a horizontal line, which is y is equal to 9. The next thing that I want to do now is find where these two lines intersect. So to find where they intersect, what do you do? So to find the intersection point, what do you do? Well, you set them equal to each other. You go 3, 2x minus 1, and you set it equal to 9. Now, you get the bases to be the same. So this will be that, this will be 3 squared. Then, once you've got the bases the same, you can now equate the indices. This will be equal to that. So that means, if I grab out this, I'm going to be left with 2x minus 1 is equal to 2, which means 2x is equal to 3, which means x is equal to 3 on 2. So this point right here is 3 on 2. Now, the final thing that we do, so this is step 3 now, is we consider, is it greater than or equal to? Well, looking at this, what do we want? Let's come back and think of our question here. It was less than or equal to 9. So we've got 3, 2x minus 1. Where is this less than or equal to 9? Well, hopefully you can see, where is the orange line beneath the green line? It's for this portion here. So that means whenever I have x values that are less than 3 on 2, I'm going to get out values less than 9. That right there is going to be my answer. So let me highlight it. That right there is my answer. Because when I have x values that are here, so think about it for a second. If I subbed in, I don't know, this x value here, whatever this is, let's say it's -1, then I'm going to get out a y value that is less than 9. If I was to put in this value here, I'm going to get a y value less than 9. If I was to put in a value over here, so this is a number greater than 3 on 2, do you see how it would end up getting a y value that's greater than 9? And I don't want that. It's only when you put in x values that are less than 3 on 2 that you're going to get a y value out that is less than 9, and that is why that is our answer. So as you can see, this works, and that gave us the same as that. Both are viable ways, and I really want you to be able to go back and forth in terms of thinking about these types of questions. All right, hopefully you found this helpful, and I'll see you in the next one.